Physics students, good afternoon. I'm Mr. Fugit here. Today, in this video, we're going to be looking at one of the problems from your homework assignment number 3, which covers over kinematics in one direction. So, this problem specifically, or this video specifically, is going to cover problem number 7, which is the first of a 4-part problem. So, again, as I work through this problem, know your values are going to be different, but the process should, in theory, remain the same. So let's read problem number 7 together. It says this: both car A and car B leave school at the same time, traveling in the same direction. I have two cars at the same point, leaving, going in the same direction. Car A travels at a constant speed of 72 kilometers per hour, while car B travels at a constant speed of 88 kilometers per hour. And my first question here is, how far is car A from school 2.7 hours later? Okay, so to give us an idea of what's going on, I'm going to draw my two cars. Okay, car A will be in red. And car A is going to be traveling at a velocity of, let's see, my value is 72 kilometers per hour. Now you'll notice kilometers per hour aren't the typical units for velocity that we've been dealing with, which is why I wanted to take some time to work through this problem. And even though the units are going to be a little bit different, our process is going to remain mostly the same. So this is car A. And car B, I'm going to do in black. And car B is traveling at a different velocity, which is 88 kilometers per hour. So it's going a bit faster. And in fact, if I were to be accurate here, I would make sure to draw my velocity vector a little bit further, just to show that I'm traveling at a quicker rate. And so car A traveling at one rate, 72 kilometers per hour, and car B traveling at another rate of 88 kilometers per hour. Now I'm asked here, how far is car A from school 2.7 hours later? Okay, so my focal point here in part 1 is just going to be car A. So I'm going to take this value of 72 kilometers per hour, see if I can use that to answer my question. Okay, so relative to car A, let's list out our variables. Delta x, v naught, v1, acceleration, and time. Okay, those are the 5 variables that I'm going to deal with here. Now, let's look at what we have. Delta x, my value for how far. Well, I don't really know that here in this problem, but I do know how far is car A traveling from school, or excuse me, how far is car A from school a certain time later. How far is what I'm looking for, and that's going to be my displacement, delta x. I'm going to put a question mark there, as well as a star. Now, the next thing I will do is, I'm told I travel at a constant velocity, or constant speed, of 72 kilometers per hour. Okay, so what that should tell me is that my speed is constant, meaning my acceleration is going to be 0 meters per second squared. And I know that my time here is 2.7 hours. Okay, now there's kind of a good question here. What should we do about this velocity? And, well, that's a good question, right? And our problem tells us that we travel at a constant speed of 72 kilometers per hour. So, what should we do here? Well, let's first turn over to our kinematic equation sheet and see if that can maybe give us a little bit of insight as to what we should do. I should have one around here. Let me grab one. Okay, so here, now that I have my kinematics equation sheet, I know that I should have an equation that involves delta x. But I'm not really sure what to do about v naught and v1. Okay, so where should we go from here? Well, we know that we're traveling at a constant rate because our acceleration is 0. What we're going to assume here is that our car is pretty much always going to be traveling at that rate. I know in our minds we should probably pay attention to our initial velocity starting at 0, but for the most part, our car is going to get up to speed pretty quickly, probably within about maybe 8 to 10 seconds based on the values that we've been looking at in class. It's not going to take us much time. And so what we can do is we can assume that our initial velocity is going to be 72 kilometers per hour, as well as our final velocity, 72 kilometers per hour. And the reason that I can do that is because the time it takes me to get up to speed is going to be negligible, very small, in comparison to my 2.7 hours. So I can assume that for the most part, I'm going to be going 72 kilometers per hour during my entire journey. So once I'm there, now what I'm going to do is I'm going to look at my kinematics equations. And the variable that I'm not really concerned about here is my acceleration. I wasn't technically told a value for that variable, and I don't really care too much about it. So I'm going to come over to acceleration and down, and that's going to lead me to equation number 4. So I'm going to list out equation number 4. It looks like this. Delta x is equal to 1/2 times v1 plus v0 times time. Just listing out equation number 4 as it's given. Now, just going to take the variables that I'm given and plug them into my equation. Well, I don't know delta x, all right? That's what we're looking for, how far we're traveling, okay? I do know 1/2, just plug that in. I know my v1 was 72 kilometers per hour. I know my v0 was 72 kilometers per hour. And I know my time is 2.7 hours. Okay, now here, we don't need to necessarily convert our time to a different unit because our unit for time is consistent in all our variables. It's all in hours. So what I'm going to do now is I'm going to simplify my equation down a little bit. I'll take 1/2. I'm going to add what's inside my parentheses. So 72 and 72. That will give me 144 kilometers per hour. And then I'll multiply by 2.7 hours. So now that I have this equation in a more manageable form, I'm going to plug in my values. I'll take 1/2, 0.5, times 144 times 2.7. When I do that, I should get a delta x. I'll do this in a new color to show it's our answer. That's equal to 194.4. Okay, we're looking for a displacement here, how far we're going. Now what about my units? Well, 1/2 doesn't have units associated with it. My velocity, kilometers per hour, if I multiply by hours, those hours on top and bottom should cancel out, and I'll be left with kilometers, which is, again, another way for us to use our units to make sure we're really applying the right process here. If I got a unit that was not in kilometers, that would probably mean I didn't really analyze my variables correctly, because my units should correspond to my variable. Delta x should always be in a distance unit, something like meters or kilometers. Now, some of you might have noticed that, well, couldn't I really just take my velocity, 72, and multiply it by my time, 2.7? You can, okay? But here's what I do want to warn you with. Okay? All of our kinematic equations are applicable only when our acceleration is constant. And while that shortcut might work now, when our velocity isn't changing, we're very soon going to get into scenarios where our acceleration is in fact changing. So make sure, don't overlook the process that we went through here. I know it might seem a little bit more tedious, but it's going to set you up for success later on. That shortcut that might work here could easily burn you later on if we don't pay close attention. So hopefully that gives you a little bit more direction on where to go with problem number 7. Good luck.